In the vast expanse of our universe, few objects captivate our imagination like black holes. These cosmic behemoths devour everything in their path, even light itself. Imagine a force so powerful that it can bend the very fabric of space and time. Black holes come in different sizes, from as small as a city to millions of times more massive than our sun. They're formed when giant stars collapse under their own gravity. The result? A point in space where gravity is so intense that nothing can escape its pull. It's like a cosmic whirlpool, spinning faster and faster as it draws everything towards its center. What happens inside a black hole? Can anything survive its immense gravitational force? These questions have puzzled even the brightest minds in physics. Today, we're going to embark on a journey to find out. Our destination? The heart of a black hole. We'll start from Earth, travel across the solar system, and witness the wonders of our cosmic neighborhood before plunging into the unknown. So buckle up, space travelers. We're about to embark on the adventure of a lifetime. Our journey begins right here on Earth. Look up at the night sky, stars twinkling in the distance, perhaps the moon shining brightly. But there's more up there than meets the eye. Let's start our cosmic adventure by leaving our blue marble behind. As we ascend, the curve of the Earth becomes visible, a beautiful blue and white sphere. As we climb higher, we encounter our first man-made objects in space satellites. These artificial moons orbit our planet, helping us communicate, predict weather, and navigate. Some are as small as a shoebox, while others are as big as a school bus. They're a testament to human ingenuity, our first steps into becoming a spacefaring civilization. Next stop, the International Space Station, ISS. This football field-sized laboratory orbits Earth every 90 minutes. From here, astronauts conduct experiments and observe our planet. The ISS is proof that humans can live and work in space. Leaving the ISS behind, we set our sights on Earth's closest celestial neighbor, the Moon. As we approach, its familiar face comes into view. The dark patches we see from Earth are vast plains of solidified lava. The Moon's surface is a stark contrast to Earth's. There's no atmosphere, no wind, no weather. The landscape is pockmarked with craters, scars from billions of years of meteor impacts. Some of these craters are so large you could fit entire cities inside them. As we touch down on the lunar surface, our feet sink slightly into the fine, powdery regolith. Looking up, we see the Earth hanging in the sky, a blue marble against the blackness of space. The Moon stabilizes our planet's axis, giving us our seasons and creating our ocean tides. Now, it serves as our first stop on this grand cosmic journey. Our next destination awaits, the red planet Mars. Leaving the Moon behind, we set our course for Mars, the fourth planet from the Sun. As we approach, its reddish hue becomes apparent. The color comes from iron oxide, or rust, covering much of its surface. Mars is a world of extremes, boasting the largest volcano in the solar system, Olympus Mons and Valles Marineris, a canyon system that would stretch from New York to California if it were on Earth. As we descend to the surface, we're struck by how Earth-like, yet alien, Mars appears. The sky has a pinkish hue due to dust in the thin atmosphere. The terrain is rocky and barren, reminiscent of Earth's deserts. The air is unbreathable, mostly carbon dioxide, and it's cold, with temperatures rarely rising above freezing. Despite its harsh conditions, Mars holds clues to the possibility of past life. Rovers have found evidence of ancient riverbeds and lakeshores, suggesting that liquid water once flowed on the Martian surface. Could life have evolved here, billions of years ago? It's a tantalizing question, but for now we must press on. Our journey to the black hole is just beginning, and we have much more to see. Leaving the rocky inner planets behind, we venture into the realm of the gas giants. First up is Jupiter, the largest planet in our solar system. You could fit over 1,300 Earths inside Jupiter. Its atmosphere is a swirling mass of clouds, with bands of different colors racing around the planet at hundreds of miles per hour. The most striking feature of Jupiter is the Great Red Spot, a storm that has been raging for at least 400 years. This massive hurricane is so large that 3 Earths could fit inside it. Next, we arrive at Saturn, the jewel of the solar system. Its magnificent ring system comes into view, a celestial wonder that has captivated astronomers for centuries. These rings are made up of countless ice particles, ranging in size from tiny grains to boulder-sized chunks. Saturn itself is another gas giant, similar in composition to Jupiter but smaller. Its pale yellow color comes from ammonia crystals in its upper atmosphere, but the real treat lies in Saturn's moons. Titan, the largest, has lakes and seas of liquid methane, and Enceladus shoots geysers of water into space from its icy surface. Leaving the majestic gas giants behind, we venture into the outer reaches of our solar system. Here, in the dim twilight of the sun's influence, we encounter the Kuiper Belt. This region is home to countless icy bodies, remnants from the formation of our solar system. Pluto, once considered the ninth planet, is the most famous resident of this cosmic deep freeze. The Kuiper Belt is like a vast three-dimensional highway circling the sun. Its denizens are composed primarily of frozen methane, ammonia, and water. Some of these objects, like Pluto, are large enough to be considered dwarf planets. As we push further out, we enter an even more mysterious region, the Oort Cloud. This is the very edge of our solar system, a spherical shell of icy bodies surrounding the sun. The Oort Cloud is so vast that some of its outer members are closer to other stars than to our sun. It's from here that long-period comets originate, making their lonely journeys into the inner solar system. The Oort Cloud marks the boundary of our solar system's gravitational influence. As we leave our solar system behind, we enter the vast expanse of interstellar space. At first glance, it might seem empty, a void stretching in all directions. But this couldn't be further from the truth. The space between stars is far from vacant. It's filled with a thin soup of gas, dust, and cosmic rays. This interstellar medium, as astronomers call it, is incredibly sparse. In the densest regions, you might find only a few hundred atoms per cubic centimeter. Yet, spread across the immense distances between stars, this tenuous matter adds up to a significant portion of our galaxy's mass. As we journey through this cosmic wilderness, we encounter vast clouds of gas and dust. These nebulae are the birthplaces of stars. Some are dark and cold, visible only as shadows against the background of stars. Others glow with ethereal beauty, illuminated by the hot young stars forming within them. These stellar nurseries come in all shapes and sizes, from small globules to vast complexes spanning hundreds of light years. After our long journey through the interstellar void, we finally approach our destination, a supermassive black hole at the center of a distant galaxy. As we draw near, the effects of its immense gravity become apparent. Space itself seems to warp and twist around us. The stars behind the black hole appear to bend, their light following curved paths through distorted space-time. The black hole itself is invisible, a region of space from which nothing, not even light, can escape. But surrounding it is a brilliant accretion disk, a swirling maelstrom of gas and dust heated to incredible temperatures as it spirals inward. This disk glows across the electromagnetic spectrum from radio waves to X-rays. As we watch, we see jets of matter being ejected from the poles of the black hole. These relativistic jets shoot out at nearly the speed of light. They can extend for thousands of light years, influencing the evolution of entire galaxies. The closer we get to the black hole, the stranger things become. As we continue our approach, we near the most crucial boundary of a black hole, the event horizon. This is the point of no return, the threshold beyond which nothing can escape the black hole's gravitational grip. Not even light is fast enough to break free once it crosses this boundary. It's as if we're standing at the edge of a cosmic waterfall, peering over into an abyss from which there is no return. The event horizon isn't a physical surface you can touch or see. It's a mathematical boundary, a sphere around the black hole where escape velocity equals the speed of light. For a supermassive black hole millions of times more massive than our sun, it could be millions of kilometers across. As we hover just outside the event horizon, we witness a bizarre phenomenon. Looking outward, away from the black hole, we can see the entire universe. Light from every direction is being bent around the black hole, giving us a panoramic view of space. But if we look inward, towards the black hole, we see nothing. Beyond the event horizon is a region of space cut off from the rest of the universe. At the very center of a black hole lies perhaps the greatest mystery in physics, the singularity. According to our current understanding, this is a point where the laws of physics as we know them break down. all of the black hole's mass is compressed into an infinitely dense point, creating an infinitely strong gravitational field. The singularity is where space and time cease to have any meaning as we understand them. The curvature of space-time becomes infinite. All of our equations fail to describe what happens here. This breakdown of physics at the singularity is one of the key reasons why scientists are searching for a theory of quantum gravity. Some physicists speculate that the singularity might not actually exist. They propose that quantum effects might prevent matter from being compressed to infinite density. Instead, there might be some as yet unknown state of matter at the core of a black hole. These ideas remain highly speculative. The truth is, we simply don't know what happens at the singularity.